Hi, my name is Madhur Behl, and I welcome you to this short video introduction to DRAdvisor, a data-driven demand response recommender system. So the idea behind demand response is the following. Say the load on the electricity grid increases at a certain time of the day, and the ISO or the utility anticipates an upcoming surge in the electricity demand. At this moment in time, they dispatch a demand response request to the end users, which are large-scale consumers of electricity like universities, industry, large apartment buildings, etc., and ask them to shed their non-essential electricity load. As a result of this curtailment, the peak is avoided and the end users are financially rewarded for their participation. Now, the challenge for the end users is to figure out what actions should they take upon receiving a demand response notification in order to curtail a certain amount of load. Essentially, the name of the game for them is how low can you go with your electricity demand without it being very inconvenient for you? And the key to answering this question lies in making accurate power consumption predictions. We want to estimate the baseline power consumption of the building since any curtailment is only measured with respect to the baseline, but we also want to predict the actual power consumption profile as a result of our DR actions. So for example, we may have several fixed demand response strategies like the one shown here, but in order to choose the best strategy during the DR event, we must be able to predict the power consumption response due to each strategy and then pick the best one. Alternatively, we might want to figure out the set point values within a strategy and synthesize an optimal demand response strategy when the event occurs. So we have built DRAdvisor, a data-driven demand response recommender system toolbox. DRAdvisor acts like an oscilloscope for the building, and it takes as input the different data channels that the building generates and uses the data to make suitable recommendations to the building's facilities manager. We have evaluated DRAdvisor using data from several real buildings like the one shown here, as well as other buildings on the Penn's campus. So this is an example for the different kinds of data which is required for DRAdvisor to work. And what is of note here is that most of the data does not require additional retrofitting of sensors to the building because as many of you know that you can virtually obtain weather data for any location from third-party websites. And underneath the hood in the toolbox, DRAdvisor uses the historical data set and builds a family of highly interpretable regression tree-based models with a different model suitable for a particular DR challenge. Here's another example where we have a fixed demand response strategy and we want to predict the power consumption of the building due to this strategy. You can see our prediction is very close to the ground truth power consumption shown in black, and the prediction error is quite low. In this example, DRAdvisor synthesizes the three different set points for the building, which lead to a sustained curtail response as is shown here. What we envision is DRAdvisor running as a service, which uses the data streams for several large buildings or a campus to make these data-driven models. And this service will have two different types of clients, the end users and the utilities or the aggregators. The end users can use DRAdvisor to figure out a better response, while the aggregators can use it to figure out better dispatch. The development of DRAdvisor is being carried out at the University of Pennsylvania, and we are continuing our efforts to improve the capabilities of this tool. If you would like to learn more about DRAdvisor or get in touch with us, then please visit this URL, which is also listed in the description of this video. Thanks for watching, and goodbye.